Okay, welcome to video 3 of day 2. In this video, we're going to look at the integral test and then look at a P-series. On page 6 of your notes, in the middle of your notes, you will find the notes for this section. The integral test says this: if you have a series, a sub n, if the series is continuous, positive, and decreasing, then the integral of the function that is equal to the series, if the integral converges, then both the series converges. If the integral diverge, the improper integral diverge, then the series diverge. So basically, you're given this function, and this is also on page 6 of your notes. As you look at, didn't mean to do that, sorry. As you look at the limit, the first thing you want to do is always the nth term test. That's where you always want to start. So we want to look at the limit as n approaches infinity of 1 over n square root of n. And we can see that when we take this limit, that's equal to 0. And since the limit goes to 0, now that means we need to do another test. If the limit had been 1 or 2, then we know it would diverge and we could stop. But since the limit is 0, we'd have to do another test. And the test that we're choosing to do, because it's not geometric or telescopic, we're going to do the integral test. So the x's are replaced, the n's are replaced with x, and I'm integrating from 1 to infinity. So I'm taking the limit as b approaches infinity, 1 to b, x to the negative 3/2 dx, because I'm just rewriting that. When I take that limit, when I take the integral, I get negative 2x to the negative 1/2. Taking the limit and setting b as b approaches infinity, I get 2. Now, because this integral has a finite number, this means that the series converges, but not necessarily converge to 2. We just know that it converges, and that's really all that we care about, whether or not it converge or diverge. The only time you will be asked to find a sum if it's geometric or telescopic. So in this example, the first thing we have to do is to write the series. So the series, I have odd numbers here, so I can write that series as 1 over 2n plus 1. And we start it when n equals 1 and goes to infinity. That's the series. Now my first step is always to do the nth term test. So if I take the limit as n approaches infinity of 1 over 2 to the n plus 1, I get 0. Does it mean it converges? No. It just means I have to do another test. And since it's not geometric, the test that I'm going to use is the integral test. So I'm going to take the limit as b approaches infinity from 1 to infinity. And I chose 1 because I started 1 here. From 1 to infinity of 1 over 2x plus 1 dx. Now, to take this integral, I have to use a u substitution. So I'm going to let u equal to 2x plus 1. du equals 2 dx. So 1/2 du is equal to dx. So I'm not going to put limits there because I'm gone to u, and I don't want to mess up my limits. So I'm going to do 1 over u, 1/2, and integrate that. I get u to the 1/2 times a fourth, because this comes out as a half, and dividing by a half gives me, so this will be times 2, I'm sorry, times 2. So this is going to give me u to the 1/2. So I have the limit as b approaches infinity of u, well, u is 2x plus 1, sorry. I'm trying to rush here because it's 4:48 and parents are coming in about 15 minutes. So this is 2x plus 1 raised to the 1/2 integrated from 1 to infinity. And as we can see with this, as I want to be, sorry. So this gives me 2b plus 1 to the 1/2 plus 2 plus 1 to the 1/2. Now, of course, this is finite, but the limit as b approaches infinity of this is infinity. And so since this is infinity, we say this whole thing diverges. Now notice that the nth term test told me that it was 0. This does not mean it converges. It just means that it possibly could converge, and we have to do another test. And the second test showed that it diverged. Okay? All right, so let's do the second problem. We want to start here by taking the limit as n approaches infinity. And when we do that, we get 0. Does it mean it converge? We don't know. We have to use a separate test. So we have to take the limit as b approaches infinity from 2 to b, because I'm starting at 2 because of this, and the natural log of x over x cubed. Now, exchanging from n to x is not crucial. It's just good notation. So what we're going to do is take this limit, take this integral, and I think I'm going to have to use integration by parts. So using isolate, I'm going to let u equal to the natural log of x. So du is equal to 1 over x, and dv is going to equal to 1 over x cubed, so that v is equal to negative 1/2 over x squared. Okay? So we have uv, so I have negative 1/2 over x squared, natural log of x, minus the integral v, which is negative 1/2, so I'm going to bring that out, 1 over x squared, du, which is 1 over x. That's just 1 over x cubed again, so I've already integrated that, so I know that this is going to be negative 1/4 x to the x squared minus 1 over 2x squared, natural log of x. And I'm evaluating that from 2 to b, and it's the limit as b approaches infinity. Now, as I substitute in, I get negative 1 over 2 x squared, 1 over 2 b squared, natural log of b, minus 1/4 b over b squared. Then that quantity minus negative 1/2, 2 squared is 4, so that'll be 8. Natural log of 2 minus 1, that would be 4, so that would be 1/16. Okay, and I'm taking the limit as b approaches infinity. So as b goes towards infinity, I have the natural log of b over b squared. So the natural log of b over b squared, that entire thing is going to go to 0. Again, 1 over 4b squared, that's going to 0 as we go towards infinity. So I am left with a finite number. Now, whatever this number is irrelevant. I don't care what that is. I just care that it's finite, because this means that it converges. And that's the only question that you will be asked, whether or not it converges. It does not converge to this number. But the fact that this number is finite indicates that it converges. And the only time you'll be asked to find the sum if it's geometric or telescopic. For the rest of them, you'll just be asked if it converges or diverges. Okay? Let's do 2 more, and then we will look at, I'll let you do the last 2. Okay? So once again, I'm going to do the nth term test first. So if I take the limit as n approaches infinity, I get n over e to the negative n over 2. And of course, this is growing faster than this, so this goes to 0. Sorry, Mr. Zamora stopped me. Okay, so then I'm going to integrate once again. Since this goes to 0, that means I have to do another test. So I'm going to integrate from 1 to b, the limit as b approaches infinity of x e to the negative x over 2 dx. So integrating this, I think I'm going to have to use integration by parts. So integrating that, I get negative 2e to the negative x over 2, which is going to give me 4e to the negative x over 2. And so the integral of that is negative 2x e to the negative x over 2 minus 4e to the negative x over 2, and I'm evaluating that from 1 to b. So if I substitute in, and again, I'm taking the limit as b approaches infinity. As I substitute that back in, I get negative 2be to the negative b over 2 minus 4e to the negative b over 2 minus negative 2e to the negative 1/2 minus 4e to the negative 1/2. Okay? Now remember, I don't really care what number I get. I just care whether or not my number is going to be finite. So I can rewrite this. Let's just rewrite this because that may help us see what's going on. I can rewrite this as negative 2b over e to the b over 2 minus 4 over e to the b over 2 minus negative 2e to the 1/2 minus 4e to the 1/2. Okay, they may come on again. As I take this limit, as b goes towards infinity, this is going to go towards 0, and so will this go towards 0. And so I am left with a finite answer, and because my answer is finite, it is said to converge. Okay? Now, for this one, we always start by doing the nth term test. So we're going to do the limit as n approaches infinity of n minus 2 over n plus 1. Well, this limit is 1. And because this limit is not 0, I know this diverges, and I don't have to do another test. That's the neat thing about the nth term test. It's a quick and dirty test for divergence. So we can easily tell if something diverges. These next two problems are in your notes. I would encourage you to do them. The answers are that they, I have to look to see. I can't remember what the answers are. They were on this page. Diverge and converge. So the first one diverges. So this diverges and this converges. And I would like for you to take a moment. I think this should be n squared as well. That should be n squared plus 1. I'd like for you to take a moment and try these and see that this one will diverge and this one will converge. Okay, last thing that we have to cover are p-series. P-series should be relatively easy because we talked about this the last time. In a p-series, if we have a variable raised to an exponent, that is considered a p-series. This will converge if p is greater than 1 and diverge if p is between 0 and 1. So 1 over n cubed, because p is 3 here, so 1 over n cubed would converge. Whereas 1 over n to the 1/2, where n is between 0 and 1, this would diverge. This test is simple, but we use it a lot when we're looking at comparison tests, which we will talk about later. There's a special case called harmonic series, and that's just when 1 over n. So 1 over n is a special case, but it does diverge, and it diverges very slowly. Okay, let's look at these examples quickly. All of these are p-series, I think. So in this case, p is equal to 2/3. Okay, and because p is less than 1, we say this diverge. We have to try to determine what p is on this one, but I have 4 9, so it looks like I'm squaring them, so I would say that's 1 over n squared. And so since p is equal to 2 and p is greater than 1, this converges. We could rewrite this as 1 over n to the 3/2. And in this case, P is equal to 3/2, so this converges. We could write this as 1 over n to the 1 over pi. And since 1 over pi is less than 1, this diverges. Our last situation, it wants to know for what values will this converge. Okay, so we know it converge if this is greater than 1. So what we'd have to do is we can rewrite this as 1 over n to the 2 minus parenthesis 3p plus 1. So this is 1 over n to the 2 minus 3p minus 1, or 1 over n to the negative 3p plus 1. So this will converge when, because they're asking when will it converge? It will converge when negative 3p plus 1 is greater than 1. So if I subtract 1 from both sides, I get negative 3p has to be greater than 0. So I get p has to be less than 0. But I've got a different answer here, so I have to look and see why I have a different answer. I distributed there. So let me look at this answer, and we will talk about this tomorrow. Okay. These are some steps you want to do as you test for divergence. You want to always start with the nth term test first. If the limit is 0, you keep going. It doesn't tell us anything. If it's not 0, we know that it diverges. The only 2 tests that we know now, or 3 tests, so we want to check to see, is it geometric, is it a p-series, or is it telescopic, or is it integral? And you want to try those in that order. Integral test is going to be the last one you want to try. So tomorrow we will finish this, and please, we'll see you tomorrow. Have a great evening.